So I want to try out an experiment, and this one I'm gonna make a homemade electronic balance. Okay, it's not electronic, all right. Okay, it's just a scale balance for measuring masses. Okay, I'm just gonna explain the concept to you. Yeah. So the concept is pretty simple because when I fill this cup with water of a volume at least this level, whenever I drop something in there, it's gonna displace this volume of water to a higher level, and that water displaced is equal to its weight. Yeah, that's Archimedes' principle. Of course. Now, okay, that depends on whether the object inside is floating. That's only we can get the accurate mass. Okay, because if the object inside is sinking and it's not floating, then the weight that I get is merely the upthrust. Okay, now we don't want to get the upthrust. We want to get the actual weight. Okay, so we all know that solid particles are always denser than water, of course. Well, that's true. Okay, there are some solid particles that are less dense than water, like wood or something. But in case you are measuring something that's more denser than water, cannot float on water, you use this method. Okay, so what I have with me is another cup, of course. Now, this cup is going to be used as a zero mass, of course. If we this one is going to be used as a scale, the one which measures the weight. So if we place it like in here, there is some water, as you can see right in there. Now if we place this cup on top here, see, it floats and displaces a volume of water equivalent to that amount. So this will be our zero mark. So this point, now if allow me to bring in something inside. Okay, I'm gonna measure the mass of this guy. So I'm not measuring, I'm just demonstrating how I'm going to be measuring a little while later. Okay, so if I put this guy inside, there you go, it has displaced water. As you can see, I'm just making it stand still. It has displaced water from our initial level there to this level right there. So now this volume of water displaced, since I have the density of water, which is 1 gram per centimeter cubed, I'm just going to find the volume of the water displaced here, and this one looks like a frustrum, of course, and we know the volume of frustrum is 1. Okay, I'll calculate the volume of frustrum. Alright, so using the volume of the frustrum, we can find out the mass of water displaced, and the mass of water displaced is the mass of this guy. Now I don't have the means to prove that that is true, but I have the theories working, so if the theories are working, then it's true. And you know, theories are proven hypotheses, and if a hypothesis is proven and it brings about theory, then that's
ability to accurately fantasize.
Basically, that's that. I'm gonna get to work
in the next pride.
Okay, so what I did actually on my phone is I made a Java program that will be executing the of course I don't know, executing, okay, never mind, it's a Java program, of course I'm just gonna say later. So it's a Java program that calculates the volume. So here is the code, the source code for the program. So I'm gonna compile the program. Okay, so right there it says enter the initial height. So if my initial height measured was 8 centimeters, I'm gonna put 8 centimeters right there. Right, so now enter the final height. So if my final L, actually height, I don't mean height, I mean L, if my final L measured was happened to be 12.6 for instance, then when I enter that, then the mass of whatever I'm measuring is 81.68 grams. All right, or that number, of course, 68 grams. Well, that's just about it, and the process is finished.